Hi, this is Mrs. Kidman, and in this video, we're going to be talking about the probability of disjoint and overlapping events. Now, before we get started into that, I do want to review over really quickly some probability notation that we might see. So, a reminder that when you see something like the probability of A, or that P of A equals something, that means that we're talking about the probability of event A occurring. Now, there are two new pieces of information that we want to overlap here. We've got the probability of A with the union of B. And so the probability of A with the union of B means that we're looking at the overlap of those two events. And so what we want to do there is we want to look at here's event A happening and here's event B happening. And we want to look at everything considered between those two. Now, we also have the intersection of A and B. So that's the probability of A with this upside down U followed by B. And the intersection means we only want the overlap of those two events, or the probability of A and B occurring. So this is the probability of A occurring. This is the probability of B occurring. The intersection is just this piece in the middle. Now, sometimes our intersection point won't exist, or sometimes our union point won't be included, and there's going to be nothing in the middle between those two. And that's what we're talking about today, is what happens with our union there. Okay, so now we have disjoint or mutually exclusive and joint or overlapping probabilities. So what does this mean? Well, disjoint or mutually exclusive are events that don't overlap. So for example, rolling a 1 or rolling a 5. Now rolling a 1 and rolling a 5 are mutually exclusive or disjoint because they can't happen at the same time. It's impossible for me to roll a dice once and to get both a 1 and a 5 simultaneously. Therefore, they're disjoint or they won't happen. So the way that we find that probability is we take the probability of A or B, meaning the 1 or 5, and we take the probability of A and add it to the probability of B. Awesome. Now, if they're overlapping or joint events, what happens is that they overlap. So for example, we're looking at drawing a heart or a 3. Well, the chance of getting a heart is a 13 out of 52 chance. The chance of getting a 3 is a 4 out of 52. But there's this special card here, the 3 of hearts. Now, the 3 of hearts is both a heart and a 3. So when we count it in both of these, we get 1 count here and 1 count here. So it's actually been double counted. And we've included it twice. By double counting it, what happens is it makes it look like the probability of getting a 3 of hearts is actually double what it is. And we don't want to have a skewed probability when we're calculating it. So when they overlap, what we have to do is we have to take the probability of the first event, or 13 out of 52 in the case of drawing a heart or a 3, plus the probability of the second event, 4 out of 52, minus the probability of A or B, or A intersects B, which is that part in the middle, so A and B. And this is going to be 1, because we have one card, that 3 of hearts, that is both of those two things. And then as we subtract those, we get 16 out of 52, which is 4/13. And so we can see that this probability actually changes. It's not 17 50-seconds, but it's actually 16 50-seconds. And we want to make sure that we're being clear there. So in the next couple minutes, we're going to go over a few examples. We're going to take a look at 3 different examples. So please hang in tight to go over these 3 things. So this first one here, we want to find the probability of getting a multiple of 3 or a multiple of 7 if we're given the numbers 1 through 20. So let's take a look at them. A multiple of 3. Well, in this first case, we've got 3, 6, 9, 12, 15, 18. So I've underlined all of those in red there. Now I'm going to underline all the multiples of 7 in purple. So 7 and 14. Now notice how there are no numbers that are double underlined or overlapped. That means that these two things are disjoint or mutually exclusive. And those disjoint probabilities means that to find the probability of getting a multiple of 3 or getting a multiple of 7, all we have to do is we have to add those two probabilities. So the chance of getting a 3 is 1, 2, 3, 4, 5, 6 out of 20, plus the chance of getting a 7, which is 2 out of 20. And that's going to be 8 out of 20 or 2 out of 5. Okay, now let's take a look at this next one. I'm going to erase our board up here. Now, what's the probability that we get a multiple of 2? Well, that's 2, 4, 6, 8, 10, 12, 14, 16, 18, or 20. And then what's the probability of getting a multiple of 3? Well, now let's look at those. We've got 3, 6, 9, 12, 15, 18, and then that's where we stop there. So I want you to take a close look here at the number 6, 12, and 18. Notice how both of those are underlined in both blue and green. So when we're looking at these probabilities, what happens is we actually counted them twice. And so if we based it just purely on what it is, what's happening is we say that we have these options out of our total. We've got 2, 4, 6, 8, 10, 12, 14, 16, and 18 that we can choose from here. We also have 3, 6, 9, 12, 15, and 18. So total, if I add all of those up, I get 2, 4, 6, 8, 10, 12, 14, 15 out of 20. So we're saying that there are 15 options here. But how many numbers are actually underlined? Well, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Notice how only 13 of them are underlined. So that actually means that we have some numbers here that are double counted, or that are double counted up there. So we've got this 6, this 12, this 18. We've included them twice in our lower count below. And we want to make sure that we don't include them twice. So we have to subtract out the probability of getting those ones. So the probability of getting a multiple of 2 or a multiple of 3 is the same as the probability of getting a multiple of 2 plus the probability of getting a multiple of 3 minus the probability of getting a 2 and a 3 at the same time. Okay, so the probability of getting a 2, well, there's 1, 2, there's 10 of those. The probability of getting a 3, well, we have 6 of those. And then we have 3 of them that overlap and are both. And so total, we have 13 out of 20 that fit there. And it's so important to make sure we take out those overlapping ones. Otherwise, we double count them and we actually see that we have 16 instead of 13. Okay, so let's take a look at this next example here. So in this case, a card is randomly selected from a standard deck of 52 playing cards. What's the probability that it's a 10 or a face card? Well, a 10 or a face card are all like value cards. So these are all value cards. So what that means is if they're both value cards, there's no way they can overlap. So these are actually disjoint or mutually exclusive events. And those disjoint events mean that I can add those probabilities right together. So the probability of 10 plus the probability of a face card. Now, the probability of getting a 10 is 4 out of 52. The probability of getting a face card is 12 out of 52. So total, we have 16 out of 52, which would be 4 out of 13. Okay, now let's take a look and compare it to this next one. So a card is randomly selected from a standard deck of 52 playing cards. What's the probability that it's a face card or a spade? Well, a face card is a value card. A spade, on the other hand, is a suit. So it's possible for us to have both of those simultaneously. And in that case, that's when we have the king of spades. Oh, a spade goes the other way. The king of spades, the queen of spades, or the jack of spades. Now, these 3 cards overlap and actually go into both categories. So this means that our 2 things are overlapping. And that means we have to do that other type of probability. So when we do that, we're going to find the probability of getting a face card plus the probability of getting a spade minus the probability that it's a face card and a spade. So let's take a look. The probability of getting a face card is 12 out of 52. Probability of getting a spade is 13 out of 52. And then we want to subtract these 3. So we end up getting 22 out of 52 or 11 out of 26. Great. Okay, so now let's take a look at this last example. Out of 200 students in a senior class, 113 of them are either varsity athletes or on the honor roll. There are 74 seniors who are varsity athletes and 51 who are on the honor roll. So what's the probability that a randomly selected senior is both a varsity athlete and on the honor roll? Well, let's take a look at this. So we've got 200 people, right? And of those 200 people, we've got 113 of them that are varsity athletes or on the honor roll. And then that means that we are left with 87 that are not. And then of those 113, the breakdown, they say, is that we have 74 that are varsity athletes and 51 that are honor roll students. Now, what I want to take into account here is these should add up to 113. Now, if we add up 74 plus 51, what we end up getting is 125. So 125 is, well, 12 more people. So what happened here? How did we end up with 12 more people when we're talking about what people do? Well, that comes down to that overlapping point. Remember how earlier when we were talking about numbers, we said that we have to subtract out that overlapping point, otherwise we double count them? Well, this is that case. Based on these numbers, where they don't say these many are just varsity, these many are just honor roll and total, and these ones are both of them. What happens is by separating them as varsity versus honor roll, we end up with those kids that are both. And those students that are both end up being double counted. So when we're talking about the probability that somebody is both, we actually are talking about this 12 people. So we've got 12 people out of 200, or 6 out of 100, which is 6% of students that will be on both. Now, it's so important to recognize that we found that by looking at where the double counting was occurring. So that double counting is very crucial in when we're doing our calculations. So this is the difference between disjoint or mutually exclusive and joint or overlapping probabilities. Again, disjoint means they don't overlap, kind of like rolling a 1 or the probability of rolling a 1 or rolling a 5. Joint or overlapping do overlap, which is kind of like the probability of drawing a heart or drawing a 3. We can also get the 3 of hearts, which is where it overlaps there. So make sure that before you calculate a probability that is an or question or a compound probability here, make sure that you are clarifying whether or not they're joint or disjoint before you do those calculations. Feel free to check out the next video on permutations and combinations.